With that, Nicholas, take it away.
Hey, good morning, everyone. It is an absolute pleasure to be with you this morning at GitHub Satellite India. Like Divya said, my name is Nickolas Means. I'm Director of Engineering for Supply Chain Security at GitHub. I'm joining you this morning from Austin, Texas in the United States, where it's about 30 minutes past midnight. So I'm doing my best to bring that late night energy for y'all. I hate to be this obvious, but a talk about software security in 2021 almost has to start by talking about Soloragate, the breach of secure systems worldwide through a supply chain attack. Malicious actors inserted code into a legitimate SolarWinds library and used it as a backdoor into systems around the world as the vulnerable library was installed via software update. Now, this was a huge incident. It got a ton of media coverage. But the reality is that most software vulnerability incidents aren't nearly this visible. In fact, you probably have one waiting to happen in your code base right now. According to the Veracode State of Security report, 83% of applications have at least one security vulnerability. Now, what this means is if your company maintains one application, you've got a 4 in 5 chance that it's got at least one vulnerability that a dedicated hacker could find and exploit. If you maintain more than one application, your odds are nearly 100%. So if you're not doing something to find those security vulnerabilities and mitigate them, you're putting your users at risk. And it turns out that developers introduce security vulnerabilities at a fairly consistent rate relative to the number of lines of code we create. Now, to be clear, this doesn't mean that you're a bad developer. It just shows that creating secure software is hard. I mean, think about it. To create perfectly secure software, you have to be right 100% of the time. To introduce a vulnerability, you only have to be wrong once. Multiply these odds across an entire software development team, and you start to see the scope of the problem. So what do? Well, again, from the State of the Octaverse report, we have some good evidence that teams that adopt DevSecOps practices significantly reduce the amount of time it takes them to remediate security vulnerabilities in their code base. Specifically, teams that run security scans as part of their everyday development practices find and fix vulnerabilities faster. Now, if we operate with the assumption that we're going to introduce security vulnerabilities into our code because they're almost impossible to avoid, then this metric, mean time to remediate, becomes the one that we care about. If we're going to inadvertently introduce vulnerabilities, then the important thing is finding and fixing them quickly. So how do we increase the speed at which we find and fix vulnerabilities? Well, we shift our security practices left. Now, what does that mean? Well, let's take a look at a fairly typical feature development timeline for a software team. You kick off a feature with some planning and some design work, you build it, you test it, and then if you have a security team look at your feature at all, it happens right before launch, after the feature's already built, and when it's extremely expensive to make a change. Because it's so expensive to make a change, only the biggest problems get fixed before launch, which means inevitably, you find vulnerabilities after your feature has already been deployed. You've exposed yourself to the vulnerability and generated costly remediation work that you now have to take care of at the expense of feature development. So what's different when we shift left? Well, first, you need to give your development teams tools to help them spot security problems early in the development process. GitHub has focused on building security tools to empower developers to discover issues early in the development process. And I'll talk more about how you can leverage those tools in just a moment. Second, you need to move your security review process from after the feature is built and tested to much earlier in the process. You want your security team to be part of your feature planning process so they can help you design security into the feature as you build it. It's much less of a review and much more of a collaboration, in contrast to the more traditional model where security is one more hurdle that you need to clear to get your feature to production, or worse, where security comes along after a feature is already launched and demands changes. This security consultation model is such an empowering way for developers to work, and it sets your developers and security engineers up for a productive, collaborative relationship instead of a contentious one. Now, these changes in tooling and practices mean that you're much more likely to find security problems early in the feature lifecycle. Like we said earlier, even though it's largely impossible to avoid inadvertently introducing vulnerabilities, you find them as early in the development process as you can, before they're deployed, and when it's still easy for you to make changes. Now, I mentioned earlier that GitHub is focused on building tooling around empowering developers to fix security issues early in the development process. So let's talk a bit about those tools now. GitHub Advanced Security is our suite of developer-focused security tools. These tools are all designed to help you write more secure code by identifying security issues earlier in the development process. Within Advanced Security, we have three main product feature areas. The first is secure dependencies, features focused on helping you understand what dependencies you're using and how you're using them. These are classic software composition analysis tools, but with a developer-focused bent. Second is secure code. These features are focused on helping you ensure the code that your team writes is secure through static analysis scanning. And finally, secure secrets. Building a modern software architecture means linking a set of interdependent tools and services, and all of those tools and services require credentials. This set of features is focused on helping you make sure that you don't accidentally leak any of those secrets. So let's start by talking about secure dependencies, making sure the code that you're importing into your project is secure and safe to use. First, I'm going to talk about a few tools within secure dependencies. First, our friendly dependency updating robot, Dependabot, which helps you keep your dependencies up to date with alerts and automated pull requests. Second, dependency review, which empowers code reviewers with insights on dependency changes in a pull request. And finally, dependency graph, which helps you understand what software you depend on. First, let's talk about Dependabot. Now, there's a couple of different things that Dependabot can do for you. First, it can help you spot and remediate dependencies with security vulnerabilities. When a vulnerability is published for the version of a dependency you use in your code base, Dependabot will let you know. In most cases, Dependabot can generate a pull request for you automatically to update your project to a safe version of that dependency. And if Dependabot can't update your code for you, say because the vulnerable version is directly specified as a dependency of another dependency in your project, Dependabot will send you an alert to notify you and to give you steps you can take to resolve the problem. Dependabot can also keep all of your dependencies, not just ones with security vulnerabilities, up to date for you automatically, bumping dependencies each time a new version is released. This keeps you from being exposed to a vulnerability discovered in an older version of a dependency, or worse, getting stuck in a situation where it's difficult to migrate off of an old version of a dependency because you're so many versions behind. Now, the key thing that I can tell you about Dependabot is that repositories that have Dependabot security updates enabled fix vulnerabilities on average 1.4 times faster than repositories that aren't using Dependabot. So if you're focused on mean time to resolution for security vulnerabilities, this is one of the key ways you can address that metric. Next, dependency review is a relatively new feature to help you understand what dependency changes are being made in a pull request. For each dependency you use, you can see how old the version you're using is, how widely used that dependency is, and what license it was released under. But the critical feature is that dependency review will flag any vulnerable dependencies for you. You can see in this screenshot, the dependency review has flagged a critical security vulnerability in the JSON Web Token package. By reviewing this at PR time, you can make sure that it never gets deployed to production in the first place. And finally, the GitHub dependency graph is the secret sauce of our dependency security features. Dependency graph helps you and GitHub understand what packages you're dependent upon so that we can bring you the valuable information in Dependabot security alerts and dependency review. The dependency graph has support for the .NET, Java, JavaScript, PHP, Python, and Ruby ecosystems. So if your code base is in any of these languages, you should definitely take advantage of these features. Okay, so we've covered code that other people are writing and that you're including in your code base. Let's shift gears a little bit and talk about making the code that your team is producing more secure with our secure code features. These are tools to help you spot potential security problems in the new code you and your team produce. Again, I'm going to talk about a few features within secure code. First, code scanning is our rich user interface for understanding and responding to alerts generated by static analysis tools, helping you make the most of the rich information that these tools produce. Next, CodeQL is GitHub's advanced semantic code analysis engine. It's focused on helping you find security vulnerabilities in the code your team produces, displaying the results in code scanning. And finally, support for third-party analyzers, which let you extend the built-in analysis of CodeQL with the results of any standards-compliant static analysis tool. So first, let's talk about code scanning. Code scanning is our rich user interface that allows you to review and understand the results from security scans right in the PR flow. It brings you the information at code review time when you're primed to act on it, when the code is still fresh in your mind. In this screenshot, you can see a CodeQL result indicating a potential denial of service attack because of missing rate limiting. It shows you the line of code where it found the problem, and it gives you rich data about what exactly is going on and the steps you should take to remediate it. You can review results from third-party static analysis tools in the same way. And our code scanning interface supports displaying results from GitHub Actions builds, as well as third-party CI/CD tools. So you don't have to move your build infrastructure to take advantage of this rich feature set. Next, let's talk about CodeQL. CodeQL is our revolutionary semantic analysis engine that allows us to scan your code base for complex patterns that indicate a potential security vulnerability. It's powered by more than 2,000 open source queries, and there are new queries added regularly by the GitHub Security Lab and the broader CodeQL community. To give you an idea of the power available to you with CodeQL, 24% of recent JavaScript CVEs and open source libraries would have been identified by CodeQL before they were ever released. CodeQL is available in C, C++, C#, Go, JavaScript, Java, Python, and TypeScript. And it can detect over 160 different categories of vulnerabilities, including unvalidated input, cross-site scripting, improper escaping, integer overflow, and denial of service attacks. And circling back to where we started, my colleague Boz, the director of product for code scanning, just published this blog post last week on the GitHub blog, detailing how you can use CodeQL and code scanning to detect traces of Solorigate in your build infrastructure where it could be used to infect other systems in your network. The security research team at Microsoft developed CodeQL queries to find traces of Solorigate and contributed those queries back to the community where everyone can benefit from them. This contribution model is a huge part of what makes CodeQL so powerful. And finally, let's talk about third-party tool support in code scanning. Code scanning is designed around the Serif standard. So if you use a third-party static analysis tool that can output results in Serif, you can view those results right alongside CodeQL results in the code scanning UI. The list on the right is some of the tools that you can easily integrate. Finally, let's talk about secure secrets. Like I mentioned earlier, modern software architectures are often an assembly of interconnected applications and services, and each of those separate tools requires credentials for integration. Our Secure Secrets product area is focused on making sure you don't accidentally commit those credentials into your repository, potentially leaking them internally or externally. We have a couple of flavors of secret scanning. One focused on avoiding disclosure of secrets in open source code, and one focused on the best practice of not committing secrets in private code. First, let's talk about secret scanning for public repositories. GitHub scans each incoming commit in all public repositories across all of GitHub at tremendous scale for known secret formats like login credentials or API tokens from partner service providers. When we find one, we notify the service that issued that credential that we found it disclosed publicly so that they can remediate it according to their standard procedures for accidentally disclosed tokens. This usually takes the form of their revoking the token and letting you know that it needs to be rotated and replaced with a new token. Next, secret scanning for private repositories. When you enable this for a repository, GitHub scans the full history of that repository to find any secrets and old commits so that you can get clean. And it alerts you if any new ones are committed so that you can stay clean. Now, these are credentials that have been disclosed privately inside of your organization. So instead of reporting them to partner service providers for revocation, we report them to you so that you can decide what to do about them. We, of course, strongly recommend revoking and rotating, but that choice is entirely up to you. These are some of the partner companies whose tokens GitHub secret scanning, both public and private, can detect for you. We'll also soon be launching in beta the ability for customers using private secret scanning to match custom patterns. This will let you detect and alert on internal token formats and tokens from providers that we don't support natively that might be found in your code base. Okay, so we've talked about features across all three security feature areas, but I have one more feature to share with you that ties all three of these areas together. It's a brand new feature that you'll hear more about in the Satellite Day 2 keynote tomorrow morning. It's our new org level security overview, and it's launching in beta for GitHub Enterprise Cloud customers. Security Overview does exactly what the name says. It gives you an overview of security feature enablement and alert counts across secure dependencies, secure code, and secure secrets, as well as a risk determination based on the number of unresolved alerts. If you unfold the view at the top, you can see a breakdown of repo risk and enablement on a per alert type basis across your entire organization. In this case, you can see that this organization is doing well with secret scanning and Dependabot adoption, but lagging a bit behind on code scanning. On the other hand, you can see that this organization has an awful lot of Dependabot alerts that they need to pay attention to. This view is incredibly powerful in helping you understand your overall security posture at a glance. And if you fold it back up, you can see a per repo risk level and alert counts for each of code scanning, secret scanning, and Dependabot. You can sort this table by feature enablement if you're working to adopt these features across your organization, by overall risk level if you're working to focus your remediation efforts on the most important repositories, and by the count of a specific alert type if you want to focus on remediating one type of alert. Security Overview ties all of our security features together in a really powerful way, and we're very excited to get it into your hands. So, to bring us to a close, what should you do next? Well, if you want to shift left, you need to make sure that everyone on your team has the tools and the information to spot potential security issues before they become a problem. You need to involve your security team early in the development lifecycle to design secure features from the start. The tools in GitHub Advanced Security can definitely help, but shifting left is a mindset that your whole team will need to adopt in order to find vulnerabilities early and deliver more secure code. If you'd like to learn more about the security tools that GitHub offers, please visit github.com/features/security. All right, that's all I've got this evening. Thank you so much for being here for my talk. I'll definitely be in the discussion later to answer any questions you might have, but please stick around for a few minutes here for Q&A with our hosts first. Again, thank you so much for being here.
Dhanyabad, Jonalu. Thank you very much for this amazing session.
Absolutely, my pleasure.
A big shout out to all the Eastern community in India. Thank you for being with us and being part of this India developer journey. Thank you, Nickolas. The night energy really showed up. Let's jump to the questions now.
Absolutely. I got the first one here from our audience. Nickolas, can you tell us more about how development and security teams work together at GitHub?
Yeah, absolutely. We have a phenomenal application security team here at GitHub. They very much have that pragmatic consultative mindset that I was talking about in the talk, to the point that engineers at GitHub are eager to consult with them early in a project. Our security team comes alongside, helps understand the threat model of a feature, the potential attack surface area that that feature might generate, and they suggest small and pragmatic changes to the design to help mitigate some of those attacks. It's very much, they're seeking to come alongside and provide pragmatic recommendations to address things that are part of the threat model of that feature, rather than resolve everything possible. A good example, my group recently completed a hack week, and there were a couple of projects coming out of that hack week that engineers, I mean, these are small features that we were able to complete in the span of a week, but still engineers on the team reached out to our application security team for consultation on them to make sure that we were considering all the angles that we needed to be. So it's this rich consultative relationship, not the gotcha culture that I've seen sometimes in previous companies I've worked at. And if security team creates that kind of environment, it makes engineers really eager to engage with them and seek their help.
Wow, that's a good cohesion going there. You talked a lot about SolarGate and the supply chain attacks. What do you think is driving the increase in these kind of attacks?
Well, I think it's all tied in with how we build software now. If you think about how software was built 20 years ago, code reuse was mostly an academic pursuit. It wasn't really a practical thing that anybody did. Now we've kind of gotten to this place where we reuse software all the time by bringing open source dependencies into our projects. And when we do that, we're inviting people that we don't know into our code base by way of the libraries that they maintain. So we've gotten really good at reusing code. It's almost become second nature to us now. And we rarely invent things from scratch, but we've really not started or just starting to wrestle with how to do that safely. We're trying to figure out how can you invite other people into your code base, but make sure that the code that you're bringing in is safe, because, if you're bringing in a library that's got 40,000 lines of code, it's pretty impractical to go and read all of that code. There has to be some component of trust built in. At the same time, we're kind of far enough along the adoption path of open source now. There's enough companies using it. There's enough rich targets using open source software that it makes a pretty rich attack surface. So we're starting to see the pace of those attacks pick up. And this is going to be, we're seeing it in the news a lot now. I expect that to continue. I don't think supply chain attacks are going to go away anytime soon.
Wow, that's very insightful, especially the shift that you explained on reuse of code in the enterprise setup as well. Thanks for that. We got next one question here. Can you talk a little more about how GitHub's tool help make you less vulnerable to these kind of attacks that we just discussed?
Yeah, absolutely. I mean, it kind of all goes back to where we started, talking about mean time to resolution. You kind of have to assume that you're going to have security vulnerabilities in your code, just because it's so difficult to write completely secure code. Again, you only have to make one mistake to introduce a vulnerability, where you have to be perfect all the time to completely avoid it. So as we're bringing these libraries in, we have to assume that we are going to introduce libraries that have vulnerabilities. So our goal isn't necessarily to make sure we never bring a vulnerability into our code base. It's to make sure that we respond to them as quickly as we can when we do discover one. And so Dependabot is critical for this, because it helps you update your code as soon as a new vulnerability is published. Again, we'll send you that alert or that pull request as soon as we've identified that dependency that's vulnerable and that it's something that you use in your repository. And dependency review is also helpful, because it helps keep you from accidentally adding a known vulnerable version of a library into your code base. So if it's known vulnerable, we want to keep it out of your code base. If it's in your code base and we discover that it's vulnerable, we want you to remediate that as quickly as you possibly can and resolve that vulnerability.
Totally makes sense. The next question is a little personal. You've been in the business of securing supply chain for a long time. What is your favorite feature, or like the best one that you love?
Oh, that's a good one. You're right. I have been working in this space at GitHub for a while, and I don't know. I have a real fondness for just vulnerable dependency alerts, because it's where we started. It was the first security feature that we rolled, the first security product feature that we rolled out, the emails that we sent you to tell you that you had a vulnerable dependency in your repository. We've iterated over those alerts a lot over the last couple of years. It used to be that you would get one email for every repository that you had a vulnerable dependency in. And now we're to the point that we roll that up to when there's a vulnerability published, we send you one email about that vulnerability that contains all of the repositories that have that vulnerability in it. So we've tried to reduce the noise. We've tried to make those alerts more useful, but it's still sort of the meat and potatoes of keeping your application secure. Just knowing that you might have one of those vulnerabilities in there and being able to identify it.
That's great. That's great to know, Nick. And beside this, obviously, security is your favorite. But what about your favorite feature in GitHub outside of security? Tell us about that as well.
Outside of security, I really love what we're doing with GitHub Code Spaces. I've really enjoyed getting to play with that feature, and I'm super excited for us to be able to roll that out to a wider audience because it's going to be such a cool thing when we do.
Absolutely, absolutely. Launching a full-blown coding environment right from the repo is no less than magic. And everybody's really looking forward to it, including myself.
Yes, it's going to be an industry-wide game changer. Thank you, Nickolas, again for joining us so late at your night and answering all the questions. Folks, remember, Nickolas is going to be staying with us. He will be at discussion, so send all your good questions to him then. Thank you again, Nickolas. Bye.
Yep, thank you. See you over there.
Yeah, bye.
Yep, and as we